Hello and good day everyone. In the last video, I've shown you how to configure the 7-segment display that is made available in Circuitverse. In this video, we are going to create a binary to decimal decoder that will convert a 3-bit binary value into decimal using 7-segment display. I have created a blank circuit which uh, indicates or shows the truth table that should be used in the 7-segment display decoder. Now, I have already discussed this in the previous video, and I've shown you already the truth table, how to create the truth table. So I've created a truth table in Excel and transferred it to a different circuit in Circuitverse. So without further ado, let us create the circuit that will decode this. However, we are not going to do this manually, but we are going to use the combinational analysis tool. Like before, we will go to tools and then click combinational analysis. In this case, we'll have we have three input names, S2, S1, and S0. That will be the first 3 bits of our binary value. And we'll have seven outputs for each, for one for each segment. We'll start with M, followed by TL, followed by T, followed by T which is top right now, TR top left, followed by BL bottom left, BM bottom middle, and BR bottom right. Okay, we'll click next, and then we'll input. So for a zero, only the middle is not used, all the rest are ones. You can figure this out, or we can copy the truth table. Okay, for a two, we start with the top. Okay, we follow with the top right, follow with the middle, okay, follow with the bottom right. Okay, file one, two. No. Let's do that again. We start with a okay. For number two, we start with a top, followed by a bottom right, followed by a middle, followed by a top, bottom left, followed by a bottom middle. Let's check that out. We'll have for two, 1, 0. This is zero pala, no? This is zero. This is a one. I'm sorry, this is wrong. This is a one. So a one is just a top, top left, top right, and the top and the bottom right. Top right and the bottom right. That's a one. Okay. And then for two, we'll have a top, followed by a top right, followed by a middle, followed by a bottom left, followed by a bottom right. Okay. So we have 0, 0. So we have 1, 0, followed by 4 ones, and ended by 1, 0. For a 3, uh, instead of a bottom left, we will have a bottom right. And then we copy the rest. Is that correct? For a 3, 1, 0, 1, 1, 0, 1, 1. Yeah, that's 3. For a 4, first we need a top left for 4, then we need a middle, and then we need a top right 4, and we need a bottom right. And all the rest are zeros. Zeros. Let's look at 4. So 1, 1, 1, 1, 0, 1, 0, 0, 1. That's correct. For a 5, we need a top first. It's just our sequence of writing. We need a top, and then we need a top left, we need a middle, we need a bottom right, and we need a bottom middle. All the rest will be zeros. Is that correct? For a 5, ones, 3 ones, 2 zeros. Yes. For a 6, for a 6 is like a 5 with a bottom left, right? It's like a 5 with a bottom left. Okay, bottom left. And it misses a 6 misses a top right. Yes, it's top right. Okay. And then the 7 is like a 1, a 0, and then a 1 with a top. Okay. So I think we're right basing on this truth table. Now we can generate the circuit. Okay. We can move this upwards. We can remove the unnecessary component added. Anyway, it's not really added. Remove the unnecessary component. Save. Okay. Let's save this first. Version 2. Okay. With a B3. Now we can already add the 7 segment display here. But in this case, I'd like to show you an example called inserting a subcircuit. A subcircuit will package our component like it's an integrated circuit or an IC. Let's create a new sheet. Let's name it 3-bit decoder with display. Okay, now we have a blank sheet. It is here where we'll place our output, which is the 7 segment display. Okay, and right after that, we are going to insert a subcircuit. Okay, we'll do that by right clicking on the place where you want to insert a subcircuit and then click insert subcircuit. We do that now. We choose among the circuits we have created, and our desired circuit is the 3-bit decoder. We click that, then we insert subcircuit. So now we can enlarge this. We are given, excuse me, a subcircuit which we can now connect. We'll start by creating the inputs. We'll change the direction to the right, label the direction to the left. This will be, we'll just copy this and paste this again. This will be our S2. This will be our S1. This will be our S2. Okay, now we know where to connect. Connect with M first. We'll put it usually at the top, so it will be easy to connect the others. Delete this. Okay, this M. And then we connect with the top left. And then we connect with the top. And then we finally connect with the top right. Okay, that does it at the top. Now we'll connect to the bottom left. We'll start on the bottom right. We'll start with the bottom right first. So bottom right. And then our bottom middle. And our bottom left. Okay. Now let's start this. Now this output. I'm sorry, we made a mistake. This output we should be connecting an input. Let's replace that. Move this all together again. Now we have a clear. Okay. Let's test this. Let's do a 1. That's 1. Let's do a 2. That's 2. 3, that's 3. Let's do a 4, that's 4. Let's do a 5, that's 5, 6, and finally 7. Now we have a 3 7-segment display, or rather 3-bit decoder with a 7-segment display. I hope it illustrates our concept that a decoder converts from binary to decimal. In the next video, we are going to create an encoder where we are going to simulate a binary keyboard from 0 to 9, which will, uh, yeah, no, 0 to 8, because that's only 3-bit, no? 0 to 7, and then we'll display it in decimal. Bye for now, and thanks for watching.